These are the homework problems for section 1-1. Please remember that as we go through these, there are multiple ways to solve any given problem. The way that I demonstrate is just one out of several different options that you have for solving. So please keep that in mind. For the first equation, we're given 10x minus 7 equals 4x minus 25. We want to collect all of the variable terms on one side. Usually we're comfortable seeing the variables on the left side, and then all of the constants on the right side of the equal sign. So if I move the 4x from the right side to the left side, because it's a positive 4x, there's nothing in front of it, I can accomplish that by subtracting 4x from both sides. And when I say from both sides, remember we have two sides of an equal sign. I only need to take that away from each side of the equal sign. If I simplify that then, 10x minus 4x is 6x. I still have the minus 7. I want to bring down the sign as well as the number. Equals, the 4x's cancel each other out, and I still have the minus 25. That sign belongs with the number, so that will be negative 25. Now that all of the x terms are on the left, I need to move the constants to the right, so that involves adding 7 to both sides. The 6x will stay 6x. My 7's cancel each other out. Minus 7 plus 7 just goes to 0. That equals negative 25 plus 7, which is negative 18. Now that I have all of the variable terms on the left and the constants on the right, I can divide to isolate the variables, so I'll divide both sides by 6. My 6's cancel, and I am left with x equals negative 18 divided by 6 is negative 3. You can always check your answer by plugging it back into the original problem and making sure that it has the left side equaling the right side. There's no denominators that have the variable in it. There's no fractions with the variable in the denominator in this problem. So checking isn't necessary, but it's still a pretty good idea. The next problem is a little bit different because it has a set of parentheses on each side of the equal sign. And the first thing that you want to do whenever you have terms grouped like that is distribute to clear out those parentheses. So in this first set, we're going to distribute that 3 to each term inside the parentheses. 3 times x gives us 3x, plus 3 times 2 is equal to 6. That's going to equal the same thing on the right. We want to distribute the 5 to clear that out. 5 times x is 5x. I have minus 5 times 6, which is 30. Now that we got rid of those parentheses, it's a problem that looks exactly like the first one. We want to collect all the variable terms on one side. It's usually most comfortable to collect the variables on the left, and then move all the other terms to the right. So if I take this positive 5x, to clear that, I can subtract 5x from both sides. 3x minus 5x gives me negative 2x. I still have the positive 6. That is going to equal, my 5x's cancel out, and again I have to pay very close attention to bringing down that negative along with my answer, so negative 30. Now I need to move that 6 over, so I can subtract the 6 from both sides. Doing so clears out my 6's. I'm left with negative 2x equals negative 36. Finally, to get the variable completely by itself, I can divide both sides by negative 2. Pay close attention to your signs. My negative 2's cancel, and I get x equals negative 36 divided by negative 2 is a positive 18. Again, it's never a bad idea to check your answer, but it's not completely necessary in this case because there's no fractions with the variable in the denominator. Moving along, we have another problem that has those parentheses, so the first thing that I need to do is distribute to clear those parentheses. I'm always going to distribute the term or the number that is before the parentheses. So on the left side, I'll distribute the positive 4 to each one of those terms, and on the right side, I'll distribute the positive 2 to each one of those terms. Doing so allows me to keep the 5. Plus 4 times t is plus 4t. And then plus 4 times minus 2 is minus 8. Equals 2 times t is 2t, plus 2 times 7 is 14. And then I still have the plus 1. Now I have some like terms, or some terms that can be combined a little bit further on each side. This 5 and this minus 8 can be combined. 5 minus 8 is negative 3, and I still have the 4t, so I'll bring that down. Equals, I have 14, positive 14, and a positive 1, so that's going to be 15. I still want to bring down that 2t, so that will give me 2t plus 15. Collecting the terms now, I can subtract the 2t from both sides. I bring down the negative 3. 4t minus 2t is positive 2t. Equals, my 2t's cancel, and I get positive 15. Now, since that's a minus 3 or negative 3, I can add 3 to both sides. My 3's cancel, so I get 2t equals 18. Divide both sides by 2, and I get that t equals 9. This problem is a little bit more involved because of the fractions. Please note that a fraction is a term. So if you see one fraction bar, like in this case, we have one fraction bar, even though it has more than one term in the numerator, that 3a minus 4 is actually 2 terms. Even though there's more than one term in the numerator, because there's one fraction bar, there's one term. Same thing with this side. One fraction bar means one term. And then the 5 is a term also. This negative belongs with this term. So really you're looking at an equation with 3 terms. 2 of those terms with the fractions obviously are a little bit more involved, but it's still just 3 terms. If you have fractions, you can clear the fractions by multiplying every term by a common denominator or a common multiple of the fractions. My denominators are 5 and 2. A common multiple with 5 and 2 is 10. So to clear these fractions, I can multiply every term by 10. So if I multiply this 5 by 10, that gives me 10 times 5. I have the minus then, 10 times 3a minus 4 over 5 equals 10 times 7 minus 2a over 2. The reason that I multiplied by a common multiple is because the fraction bar means divide. So because I am dividing, to clear out division, the opposite of division is multiplication. So what's going to happen is that these fractions will clear out using the idea that a fraction bar means divide. So let's see how that works out. Before I do that though, we'll start off with the 10 times 5, and 10 times 5 is just 50. Minus, I'm using the green now because I want to really emphasize this point, I have a times 10 divided by 5. 10 divided by 5 is 2, or 2 over 1. So this 5 will completely cancel out, and this 10 will become a 2, because 10 divided by 5 is 2. The fraction bar means divide, so I took 10 divided by 5 to get 2. This becomes then minus 2. Okay, so that 2 is there. And then the numerator, I didn't touch. Okay, so nothing changed about that numerator. So I will keep it as 3a minus 4. Notice how I'm still keeping it in parentheses, because even though it was one numerator, it was made up of 2 terms. So I wanted to remind myself that that 3a minus 4 represented one numerator. So I kept it in parentheses. We're going to do the same thing to the other side. I have 10 divided by 2. 10 divided by 2 is 5, so the 2 cancels and this 10 can become a 5. So this really equals 5 times that numerator that I did not touch, so times the quantity 7 minus 2a. Now that I got rid of those fractions, I can proceed just like a regular problem. I still have that 50. I'll distribute the minus 2. Remember, that negative is stuck to that 2, so I'm going to distribute that minus 2. Minus 2 times 3a is minus 6a. And then minus 2 times minus 4, negative times a negative, is a positive 8. equals, I'll distribute the 5. 5 times 7 is 35, minus 5 times 2a is 10a. Combine my like terms over here. I have a 50 plus 8 is 58, minus 6a equals 35 minus 10a. So more and more it's looking like a problem that we have been working with before and that we're pretty used to. Okay, so let's see. I can move this 10a term over to the other side by adding 10a. Because it's a minus 10a, I'll add 10a to both sides. I bring down the 58. Minus 6a plus 10a is plus 4a. Equals, I still have the 35, and my 10a's cancel each other out. I will subtract the 58 from both sides. My 58's cancel, so I get 4a equals, let's see, 35 minus 58 is negative 23. Now I can divide both sides by 4. My 4's cancel, so I get a equals. This problem's a little bit different because negative 23 divided by 4 does not give me an integer answer. I can't simplify that fraction anymore. It is perfectly acceptable to leave your answer as an improper fraction. In fact, in some cases it's preferable, so it's not a bad idea to get into the habit of leaving your answer as a single numerator over a single denominator. As long as your fraction is simplified, in other words, as long as there's no number that you can divide both the numerator and denominator by, this is a perfectly acceptable answer. In this case, if we took 23 divided by 4, our decimal would be negative 5.75. It would be a terminating decimal. That would also be acceptable, but it's still, again, not a bad idea to get into the habit of leaving your answer in this form, negative 23/4, because that is an exact answer. Later in the course, we'll be talking more about exact answers. Same type of problem this time. We have